Ladies and gentlemen, I feel very honoured on behalf of Cavendish Group to be delivering the welcome address to the 5th Future Downstream event. It's fantastic to bring our oil and energy communities together once more, this time virtually. And we're incredibly honoured to have such a strong lineup of refineries, operators, chemical manufacturers, and technology innovators contributing to the programme. May I first thank our official digital twin partner, Kongsberg Digital, who've continued to offer us tremendous support and value to our event. I would also like to extend our gratitude to the Future Downstream Advisory Committee, who have helped shape the theme of the agenda over the last few weeks. Whilst technology can become a source of positive change, we all recognise there are several challenges that need to be overcome to fulfil its potential. Complex and marginal, the downstream industry must quickly act to shift to a new energy mix where digital technologies will play an integral role in transitioning to a low carbon future. Companies need to build foundational capabilities in areas such as data and analytics, technology architecture, talent, culture, and cybersecurity. Developing these capabilities will prepare the organisation for ongoing digital transformation, regardless of changes to the underlying technology, and therefore successfully connecting operations, maintenance, supply chain, safety and security. Creating a modern and accessible ecosystem is fantastic, but at the same time, it must be secure. Effective transformation, therefore, requires trust and empathy, and never forget about the end users who won't care as much for the technology, but more for their pain points. It's fair to say that after speaking to numerous operators, that you should always build a digital framework with your team, not for them. Asset performance management and implementing an effective APM strategy remains one of the greater challenges. The increased role of predictive maintenance and digital twin will be crucial to unlocking the true potential of an asset. The role of performance forecasting has never been so significant. Aging infrastructure and expected downtime are commonplace, so improving asset sustainability is a key priority for the sector. AI has the potential to be a real game changer, but safeguarding and utilising the existing workforce is paramount. Integrating AI and real human talent can accelerate innovation and resilience, but collaboration between professionals, providers, operators and vendors is critical for AI to thrive in the downstream sector. We should always remember that behind any artificial intelligence, there's a human driving this process. At the same time, companies need to invest in modular security and zero trust procedures, ensuring protection against AI-driven threats. Developing a circular economy will require a number of solutions ranging from electrification, energy storage, CCUS hydrogen, recycling, and bio-based feedstocks. And therefore, it's vital we drive science-based prioritization and understand the quick wins and most impactful solutions. When addressing also carbon neutrality, it's essential to decarbonize heat, and regulators therefore need to provide incentives, policies, and frameworks to drive this transition. Finally, I want to thank the Cavendish team for making Future Downstream possible. And on behalf of Cavendish Group, I wish you a wonderful event and hand you over to a fantastic thought leadership presentation titled Framework for an FPSO Digital Avatar by Pedro Vieira, Data and Information Technical Manager for Petrobras.
Okay. I'm Pedro. I work for Petrobras for 20 years now. I work with data and information for the engineering vice presidency and used to be the automation manager, also the digital engineer manager. So I bring up together all the IT, OT, and ET. And I'm going to present to you now a paper that has been presented in the last Offshore Technology Conference in Houston about the framework of what we call digital avatar. Okay, this work, there's a disclaimer here. You will have enough time to read it.
Okay.
And this work has been done together with many colleagues from Petrobras, from various areas, the operational area, the digital transformation area, the digital engineering and operations area. And I thank them all for contributing with the article. One of the authors, the main author is Italo, and we contributed to him for this framework. What's the main problem we are trying to address? To have a common way of calling things. So everybody talks about digital twin. It's a very it's a kind of a buzzword in industry. So we must put it in perspective, because we do need a very robust digital twin to work as a kind of a substrate for our digital transformation in the oil and gas. So we divided this buzzword into many domains and many enabling technologies, as we will see in the framework. And we are going to discuss this framework here to be sure that we are talking about the same matter when we talk about digital twin or digital avatar. So the word digital twin was first applied to manufacturing, and only later it came to the oil and gas industry. And because it was first applied to manufacturing, has a kind of a mindset that is very, very different from the process industry. For example, the digital twin originally was designed to replicate a physical asset. It was focused on products. So when we are talking about the process industry, we didn't have a product digital twin. For example, in oil and gas, we have the oil, the gas, the diesel, and aviation fuel, and every product that we have. It doesn't make any sense to have a digital twin of this process flows. So the first thing we have to know is the original version or original approach of a digital twin from manufacturing. It does not apply directly to our oil and gas industry. Okay, so when we made this survey here in Petrobras, which technologies or implementations are associated or contribute to a digital avatar or digital twin, the answers were very, very diverse. So they talk about equipment twins, so 3D models, simulations, asset management, ERP, plant information. There is more connected to operations. And at the end of the day, when we talk about a digital avatar or a digital twin, what are we talking about? That's the main question of this presentation, okay? Sure. So based on these answers, we have put some of the domains here. We have put them together in 4 domains. So why are we proposing a digital avatar approach? Because a digital twin, nothing is more different than the twin brothers, okay? So the word avatar, everybody talks about the movie, the Avatar, but it comes very long before it. Avatar derives from the Sanskrit and means descendant of. So the avatar is connected to the controlling of the avatar. So if you saw that movie Avatar, you just have one consciousness that controls both bodies, the original body and the avatar body. That's the main reason what we propose the use of avatar, because we do not want to have that segregation between the digital asset and the physical asset. Okay, so if they are twins, for example, by the end of engineering design, uh, they will be separated forever. That's that's what we saw in many of projects in the industry, because at the end of the design, at the operations phase, for example, the digital asset is abandoned because it does not reflect anymore the reality of the physical operations. So with an avatar, we have all these assets, all the digital assets and the physical asset connected in real time, so they will be useful during all the lifetime of the installation. Okay. So let's talk about the framework. The framework is divided in four domains. Okay, one, there is much common, as we saw the 3D models, the spatial domain. There is at the left upper corner here. The physical chemical domain, there is directly connected to the plant, the process plant. The in-time and real-time domain that is connected to the operations, uh, especially in the automation, industrial automation, and real-time optimization and such things, and what we call the characteristics domain. There's a kind of miscellaneous and everything that is not fit into the other three domains. So let's take a look. With this, each of these domains, we have three or four what we call enabling technologies. For example, the spatial domain, we have the cloud, the laser scan or point cloud technology, the 360-degree photos, and the 3D models. What is it important to separate the spatial domain from physical chemical domain, for example? Because many companies, they have initiatives in standardizing the digital twin, focusing on just spatial domain, because their problem is they need to exchange information about, for example, a laser scan or a point cloud or 360 photos or 3D models. And is this a digital twin? The answer is yes. It can be referred as digital twin or digital avatar, but it's not a complete digital twin, because it's a kind of geometric or spatial digital twin. For example, today we have three major initiatives in trying to standardize one or more of these domains. The first of these initiatives is running inside ARC, Advisory Group. There is the Digital Twin Work Group. The second one is running inside IOGP. There's International Oil and Gas Producers inside the Digital Transformation Council. And the third one is running in the Open Group with a proposal by Petrobras for Open Engineering Data Universe. There probably is going to be a new forum for standardizing all of these four domains in the next year, 2025. Let's talk just. I started with the spatial because it's very, very common to have digital twin just connected to a spatial domain. But we have physical chemical domain for example, with smart PNIDs or smart schematics, simulation and emulation. There's a little difference between these two. The simulation reproduces the behavior of the chemical plant, for example, and the emulation is a copy of a system. For example, emulation of electrical system, emulation of automation system. They both serve the same thing, to have the physical plant represented into a digital asset. But one is by simulation means and the other one is by emulation means. Okay, and we also have equipment twins. The physical chemical plant, so it tries to model and it tries to bring to the digital world all the characteristics of the physical process, chemical process, okay, including equipment and also the physical chemical behavior. The in-time and real-time domain, it stands for what we call multivariable advanced control and real-time optimization, IIoT, automation system, and asset management systems. Okay, so it's more connected to the substrate of the process plant. There is all the control part of the plant, not the plant itself. Okay, so we have spatial, we have physical chemical, and we have in-time and real-time domain. And the characteristics domain, it's more connected to what we do with information. So planning and control, for example, ERP connections, knowledge management, and such things. So they are a kind of a second step over the first step that is done by the three major domains. There are spatial, physical, chemical, and in-time and real-time domains. Okay, so again, when we talk about a digital avatar, it's a digital asset connected to a physical asset. Some authors call them phygital assets, with this main three domains: spatial, physical, chemical, and time, real time, and also the characteristics domain or the management domain, if you want. Only if we have all these four domains connected to a digital asset, we can say we have a digital avatar. Okay, but for this to work, we have three pillars. We need data standards and we need data governance. We need what it's referred in industry as IT, ET, OT convergence. That is information technology, engineering technology, and operations technology convergence. So we must have the data available, the data flowing. So with these three pillars, we must ensure that the data is flowing. So we must have standards, we must have convergence in the architecture, and we must have scalable IT. So these are the three pillars that support the digital avatar. And our North Star, what we need to get with this digital avatar is digitalization, automatization, modularization. Okay, we need to have this digital asset to be useful for the business. That's the main concept behind the digital avatar. It's not because it's good to have. It's technological. It's a technological advancement or something like that. Okay. We have more slides here talking about the models. Well, in Petrobras, we have, for example, in 3D models, we have more than 30 million attributes. For example, almost 45,000 pipe runs, and more than 11,000 instrument pieces. And we in Petrobras, we hand over the digital asset to the EPC by the end of the executive design. So we don't have printed documents or PDFs anymore. It's all about the database that is handled to the EPC during the bid. So we do have at the end of the executive design or the basic design with a feed, we do have a digital asset, and that digital asset is very, very robust. We have some examples here from Ativo 360. There is a kind of a point cloud or 360 photos. Just to remember, this is all about the spatial layer or spatial domain. In physical chemical domain, we have so much different equipment, for example, that need to be referenced by the manufacturers. So it's very important to have a standard so the manufacturers can hand over the models of equipment to us, and also to use the simulators and emulators to model the process, the chemical process. And also in the physical chemical layer, we have the smart schematics. There is a very, very important thing to do with digital assets, a kind of a 2D. Some people call that a 2D modeling, that not using the CAD drawing tools anymore, but CAE 2D to make the PNIDs more intelligent. In real time and in time layer or domain, we can make causal correlations and talk about integrity and optimize, for example, the revenue from a kind of a working state for the process plant. And in the characteristics layer or the management layer, we must go from a document-centric exchange of information to a data-centric environment. Okay. This is a comparison between the traditional digital twin with a digital avatar. Okay, digital twin. So it began with the manufacturing, and it's product oriented, and digital avatar is asset oriented. This is very, very important difference. So the digital twin was made to fully replicate the product. Digital avatar, it's about enhancing the asset capabilities. So we have individual complex in digital twin and a system complexity in digital avatar. Okay. And digital twin is focusing on optimizing individual performance, and the digital avatar is more system oriented, so it needs to maximize the value extraction from the entire system with a global financial or economical function. Okay. And finally, the conclusion is that the digital avatar concept creates a common ground for debate within the industry. We must know, what are we talking about? Which one, two, three, or four of these domains are we talking about, so we can establish the pillars to make this digital avatar work, especially when we're talking about standards. Okay. This framework it provides representation layers and with the representation layers or domains, the enabling technologies, the conceptual pillars, and the guidelines to have a common representation of a digital asset. Okay, what we call digital avatar. It may be used to manage the digital products, or prioritize ideas and identify gaps in current digital strategy. Okay, it serves as a starting point for companies with a digital avatar implementation in the early stages. The digital products that we presented here was very fast. Is a path like Achivo 360 to implement the concept. If somebody has interest in knowing better our digital products in Petrobras, you're free to send me an email or Italo or any of the authors, okay? And additional work is needed to expand the concept beyond surface facilities or downstream facilities. This is very important because I know this is a downstream Congress event, and this concept applies to upstream like OTC and also for downstream. And my final invitation is that we must think our digital assets in a more structured way, like this framework, to make them work from the early stage of our projects, such as conceptual design, until the end of the life cycle of the operations. Okay, this is the approach we are using in Petrobras, and we invite you to know better, to read the article from OTC, and to open channels to talk to us about this concept of a digital avatar. Okay, thank you very much.
Thank you very much, Pedro. And I must say it's Pedro Vieira, not Vieira. I made a slight error in the name, so my apologies. Fantastic presentation to start the day, and it's really, really important. Even though it was related to offshore technology, FPSO, it's good that Pedro mentioned at the end how it can be related specifically to the downstream industry. I think a lot of the technology is agnostic, so we're looking at other sort of areas that can be also applied to the downstream industry, and that was really, really exciting. Very impressive stuff on the digital twin, which I obviously one of my favorite topics. Great that you referenced a lot about how it's key to unlocking a lot of the siloed data, put it into a contextualized data. But also, I love the line about moving from a document environment to a data-centric environment, which I think is really, really key in terms of how we push through digital transformation. So my name is Adam Soroka. I am the CEO of Cavendish. Welcome to Future Downstream. Really funny to present virtually again because I haven't done it for so long. So it's a fantastic feeling in a way. The only thing is I don't have the crowd in front of me to sort of guide me if I'm talking too much. So I've got to sort of try not over talk if I can. I do tend to get quite into the topics as well. So, but I really like that as a start. Just a couple of house points before we get onto the opening panel. Obviously, for all of you that are logged in, do use the chat bot because the chat box. Sorry, because I think a lot of the speakers or moderators that are part of this event, and I'm sure all of you know it's quite difficult to get speakers in one place at one time. Do ask questions. Do ask them what you want. I think it's really a really good opportunity for you just to say, right, you know, maybe what's on your mind about technology. They're real brainiacs, a lot of them are, and I'd like you to sort of make the most of it as well. So do use the chat box as much as you can. Enjoy it. I hope you enjoy the event, and I hope it sort of inspires you in terms of what we're trying to gauge towards the downstream industry. This event is talking about predominantly digital technologies, also how digital technologies enable energy transition. So we do have a couple of sessions as well that talk about the circular economy, about decarbonisation, which are really key points, as I mentioned in my opening remarks,